It's December 15th, 2019. My name is R. Crosby Lyles, and this is News from the Can. This is Dr. Peter Carter, and this is on Dick Breeze's channel. And he's basically kvetching about how things have never really changed. And COP stands for Conference of the Parties. I had to look it up because, Conference of the Parties is the supreme decision-making body of the convention. The parties meet annually to review progress in the implementation of the convention, where other instruments that support the implementation of the convention are proposed, evaluated, and approved. The first COP was held in Berlin, 1995. To date, 24 COPs have been held. United Nations Framework Convention, UNFCCC, is the international response to climate change. It is a treaty that establishes the basic obligations of the 196 party states, plus the European Union, to combat climate change. It was signed at the Earth Summit in 1992 and came into force in 1994. So he's kvetching about how it's set up to fail because of the way it has to be a unanimous vote, and it only takes a couple of countries or a country or so to object, and so they just really never get anything done. It's basically like a dog and pony show type of thing. And I still don't hear anybody talking about the fucking elephant in the room. By the way, all my videos now are 18 plus. Meaning that they're, the audience is intended for 18 plus. So, there's various reasons for that. Basically because I can't take a $42,000 hit, and that's what it really boils down. It's just bizarre. I mean, really, things are weird and getting weirder. So, but I want to point out a couple of interesting things. First of all, in this particular section, I'm not gonna play it because I want to get through this because there's a bunch of ideas here at work. He talks. Peter Carter here is talking about. Dr. Peter Carter is talking about how Chile is going through a massive drought. Africa, sub-Saharan Africa, is going through. They have some what he's referring to as super droughts, and Australia is going through a super drought. So bear that in mind, and let's truck on over here to Climate Reanalyzer so I can show you something. We're going to look at the temperature anomaly. If you were a believer, it's like everybody challenges everything these days. So whether you think these guys are legitimate or not. All right, now here we are. If you click on the globe here, you can get a different view. And this is Antarctica. So we're looking from the bottom up. And you see all this blue out here. This is the 2-meter temperature anomaly. So that means that's the air temperature up to 2 meters above the surface of the Earth, which could be ocean, it could be land, ice, whatever. And you see all this blue here. And that's what's going on in view of, this is ozone, this big trench eating around the equator. And, I have to go through and go back through history and see what these accumulations have been like in the past. As far as I can tell, this is sort of unprecedented. This band of CO2 is unprecedented. This is something we've never seen before. This is the interesting bit. So this is methane. And there's this artifact here. This line right here, this is actually the North Pole. That's actually the same point. The top of this graph here is actually just one point because this is a globe and this is the this is the South Pole here. So that's actually one point. And as we step forward, so that's methane. This is carbon dioxide. You can see the same artifact right there. And here is ozone. So as I've said before in other videos, there's a interplay between methane, ozone. Methane actually will produce ozone in the lower atmosphere because volatile organic compounds like methane, formaldehyde, things like that, or they're actually like something called a reaction body that actually allows ozone to form. If you had pure air and put it in a jar, you could wait for 1 million years and you would never see any ozone in there. I mean, you might maybe see some off, a little bit of ozone, but you won't see an accumulation. spritz a little bit of methane in there or some volatile organic compound in your jar of pure air. The next thing you know, bada boom, ching bang, you got ozone. It's just one of those things. So methane produces the ozone that actually ends up eating it up as it gets to a certain level. This is in the stratosphere. This is at 50 hectopascals, which is a pressure level. 50 hectopascals is basically 50 millibars. It's about 60,000, a little above 60,000 feet at the equator, which is in the stratosphere. And in particular about the stratosphere is stratified. So there's no vertical mixing, and the air moves horizontally between the equator and the poles. And it can move pretty rapidly too, 100-something miles an hour. It moves along pretty quick. So this is all at the same level, 50 hectopascals. It's in the same place, essentially. And it looks very similar, right? So this accumulation, this is a footprint. This shows you that this accumulation is pretty much a result of methane. And that methane, just to reiterate here, I've gone over this a few times. I want to be careful that I don't repeat myself too much, but I'm trying to get to a bigger concept here. Here's your Arctic. Looking down, that's the North Pole right there in the middle. And you can see all this methane. This is at the surface level. Right here you can see that's the surface level. This bit right here is in, I can't remember what province that is. Right there. Saskatchewan is over here. And it's not right off the top of my head. I can't remember I have to look at it. But anyway, so here's Washington State, and here's California. There's like an ass load of methane coming off of fucking California. And in the eastern half of the United States, look at all this methane coming off of here. And then you go over here, this is Russia on this side. And you got Sweden and Finland and Norway. And there's just a ton of methane coming off of there. And this is China. The rice fields of India and China give off the most methane in the world. That's the biggest source of methane in the world. This is Central Europe. This is Italy. Look at all that methane coming off of there. Then over here, of course, you have Romania, and this signature has to be from the use of natural gas. It waxes and wanes, right? It has to be. And then these are the British Isles right here up in the top left-hand corner. The way this is waxing and waning here, this is UTC, which is Universal Time, which is basically Greenwich Time, which I believe is this line right here. So when it's at 0, which are these larger hash marks here, then you are talking about midnight, essentially. So midnight UTC right here, midnight in Great Britain, tons of methane. That's midday. Not so much. It's got to be from heating. It's got to be from natural gas heating homes and things. I mean, is there that much agriculture that you'd have that much methane coming from all these different places in Italy and Eastern Europe and stuff? That's just absurd. This has to be from gas utilities. And in Russia, it's probably from gas, some from gas production. If we had a lot of methane coming out of the ocean, which supposedly there's some areas where it's bubbling up, and then lake in and around the Arctic, now it's December, but some of these areas are supposedly just bubbling like ginger ale, they say, right? There's no evidence of that here. This is the Capernicus satellite. This is all land-based. It looks like utilities. It could be sewage treatment even, because you're going to get some methane from that. You get methane from cows and agriculture. All right, so I want to mention potholer real quick. I like potholer. I'm not a climate denier. Let's just get that out of the way right now. Okay, I'm not going to give away his whole plot line here, but basically what he's saying is he's making a case for peer-reviewed studies. And that what you get on YouTube is you don't, he's discussing how bullshit conspiracy theories get floated. And that, there's a lot of, that's some people, that's their stock and trade. That's not what I'm doing. Basically, I get an idea about, I want to know I want to know what's really going on. And this is the problem with peer review. One of the problems with peer review, and it's been mentioned before. Actually, it was mentioned by Sabine Hassenpfeffer. I watch her videos all the time. I'll put a link. I'll show you the link. She's talking about peer review and that people get stuck in lanes of thought because you can actually get punished for getting outside of a certain established box. There's like money in finding out. You get paid more money if there's a crisis. So peer review is important. I'm not poo-pooing that at all. But, you go to school for 10 years or however long it takes by learning stuff that other people came up with. And then it's time to get your master's degree or your PhD so you can make the big bucks. And you have to have a thesis. You have to write about something that's your thing. And it'll be some, slice of the pie that's already out there. If you got somebody who's just been a professional student for years and years, and well, shit, man, it's time to get a shitter, get off the pot, get a PhD. Rachel Maddow's got a PhD in something or another with women's studies, some arcane something or another. Breast cancer or this or that, and or incidents where I don't remember what it is exactly. I'd have to look it up, but it's something pretty arcane that nobody really gives a shit about, and that's what a lot of people get their PhDs in, you got to do a dissertation. So you get an idea, and then you get peer review. Then you got to go around and fuck people's dicks and shit like that to get your paper. So basically what Dr. Carter is saying is that since 93, it's been set up to fail. Because you only need a couple of countries to object, they can never get together. They can never actually come to any sort of agreement. And the United States pulling out of the Paris Accord and all that kind of stuff, it's just theater, essentially. But he goes on to say that the amount of carbon dioxide that we have in the atmosphere right now is more than we've had for 40 million years, I think he said, 25, 40 million years, something like that. And then we're on this fast track, that it's accelerating, that the reactive gases that are in the atmosphere, the greenhouse gases, methane, carbon dioxide, and even NO2 are rising at an accelerating rate. And he's talking about collapse of the biosphere. Subsequent collapse of the biosphere. Now, there's a couple of things that they talk about when they talk about collapse of the biosphere, the droughts and fires as being a symptom of heat. That may not be true. And I'm going to show you something. Because in this bit here, the link is in the description right here where I have this marked. This is minute marker 1535. So somewhere in here he's talking about super droughts. Super droughts in Chile, that we're talking about droughts that will last for decades perhaps, a super drought in sub-Saharan Africa, and a super drought in Australia. So I'm going to go over here to climatereanalyzer.org, which is a product of the University of Maine. It's the Climate Change Institute, University of Maine, is where it comes from. That's a product of. This is the 2-meter temperature anomaly. That's the departure from whatever mean it is that they decided is relevant. The blue is obviously lower and orange is obviously higher. Now, there's some particulars in there with that, by the way. Sometimes I've noticed the orange is related to precipitation. But here's a little interesting thing. We're looking at the South Pole right here. There's Australia. There's Antarctica. And it's in the middle of the summer down there right now. So we're talking about it's December 15th here. So we're getting to be summertime. Maybe it's actually a little bit before that. So We're talking about June, late June for the northern hemisphere, which, by the way, every summer, year on year for the last, since 1979, the temperature in the Arctic and the north has been nominal. In other words, white. The coloration is white. Every year, year after year. I've already done videos about this. But anyway, so here's this. And this is what I was going to look at next. This is sea surface temperature anomaly. And that's a lot of blue around Australia. It means that the sea surface temperature is anomalously cooler. Okay? Now let's look over here. Same thing. This is Chile right here, right? Blue water. Blue water. And also down here. And here's Australia. Now this is actually, the water's a little warmer than it has been. But up until this month, the anomalously cool sea surface temperatures has been much more widespread around Australia. Cold water actually dries out the air. This is why the air is dry around California, because these cold currents come down off the coast and dry the air out. That's why there's a desert here. You know, those mountains are there, and the snow drops the precipitation out, and it just gets dry. And they have fires, and they've had fires. They have fire seasons, and they have fires every year. You want to know how many fires they have? You can find firefighting movies about California that go back to the 40s that have to do with airplanes dropping water on fires and things. I mean, that's just a thing in California. And they have a lot of fires in Africa and fires in South America because, like in India, they burn the old crops before they replant. And that creates a lot of pollution. They had a really intense pollution event this past year in India because of that. I mean, people dropping dead, essentially. So there's your sea surface temperature anomaly. That's, there's a lot of warm. It's a mixed bag. So, he's talking about they can't get it together and that there's going to be a collapse. And my argument has always been, what is at the endpoints? The reason that scientists fret about the CO2 thing, here's your signal, your temperature signal. This is 1 million right here. This one right here is 1 million years. This is the glacial and interglacial period. So the interglacial periods are these spikes, and then it dives down. And so the Earth is in a glacial period longer than it's in an interglacial period. And those spikes, well, that's a period of advanced global warming. That's a runaway global warming right there. I mean, really, right? That steep ascension is runaway global warming. And then it turns around. Well, what the hell causes that turnaround, folks? It's methane. Obviously. But what they're afraid of is that, well, the CO2 goes up and up. And so imagine this graph in reverse. And we're over here. And because the CO2 is going up and up, they're afraid that it's going to cause what's called a translation in the signal. That the translation will go up above the zero line here. So you'll notice that the amplitude of this signal is less, and the whole thing is translated up. Well, here's what I want to know. What was the pH of the ocean at that point? They got a chicken and the egg thing going on. Which came first? The low pH of the ocean or the high CO2? Did you end up with more CO2 in the atmosphere because the oceans were acidified by hydrogen sulfide and sulfur dioxide deposits from volcanoes and stuff like that? There's a little bit of a chicken and the egg thing going on there. In fact, what can happen is that you don't have enough CO2, where the plants become starved for CO2, and because of that, there's a big die-off of plants because of the lack of CO2. And when you have that die-off, all of a sudden, well, they all die at the same time, and then there's this massive production of methane and CO2, and then you have a period of advanced, see this dip down here, right there at the bottom end of that, where maybe there's a big freeze, frost, or whatever, and a whole bunch of plants die off, and then it causes it to go back up, all related to the Milankovitch cycles and stuff. And basically, the way I look at it is I don't throw anything out. I'm not going to throw any data out. I'll say, okay, well, we'll look at the Milankovitch cycles. Yeah, you got to factor that in. Factor in the galactic cross and factor in the sun cycles and the flip of the magnetosphere and all that stuff. Factor everything in. But ultimately, it's going to boil down to how much energy is hitting the surface. How much energy is being absorbed by the surface? That's gonna drive temperature. And what's gonna cause that turnaround is water vapor hitting the stratosphere. Water vapor and/or other greenhouse gases hitting the stratosphere. And the natural process that we see in that is happening right now. And I don't hear anybody talking about it. And I think the reason that they don't talk about it is because when you see this, the cat's out of the bag. I mean, that's a wrap. And I'm not writing this because I'm trying to get to these ideas. I put this video up recently about why this is news, and I got this. I sent it to my brother in a text, and he sent a text back, and he's making fun of the bullets, and stuff, and he just basically said he doesn't understand what the fuck I'm talking about. And I asked my wife, what's do you understand what I'm talking about? She said no, nobody understands what the fuck I'm talking about. I'm like, okay. Nobody understands that it's relevant that this band of 1,000 parts per million of CO2, bada boom, within the last 6 or 8, 9 months, this band of CO2 appears out of nowhere associated with a band of methane. It looks exactly the same. You look at that, you see this here, and so this is methane. It's at 50 hectopascals, about 60-something thousand feet. You see this artifact here coming up like this. Same thing, 50 hectopascals, CO2. This artifact coming up here, 50 hectopascals ozone. And this is lower. This is a lower concentration, which means it's being eaten up. Ozone gets eaten up by methane. Methane produces ozone, and ozone eats up methane. Just depends on what the circumstances are. But there it is. There's that artifact right there that shows you that this accumulation of CO2 is from methane. And it's from anthropogenic sources, too. So that's the North Pole. And I've heard stories from different sources where they talk about, the water's up in this area right here, somewhere between the Chukchi Sea. It's like the Chukchi Sea and the East Siberian Sea, something like that. If the waters out there are bubbling like ginger ale, if that was true, then you would see it coming off. This is the Capernicus satellite, if you want to believe the Capernicus satellite. If not, what are you going to say? I try to look at the GOES equipment and stuff, and it's a little hard to find their data. You're going to have to go pry through that stuff and look at the older data. Now, it's Have a Think. The Have a Think guy gets on and he says, that since 2007, the amount of methane in the atmosphere has gone up, and it's from fracking. The price of oil was about $22 a barrel in 2002, and then they started the Iraq war to basically drive up the cost of oil so that to make fracking profitable. That's what got the fracking business going in the United States. So they ended up fracking for natural gas, and they make fuel out of natural gas. Synthetic motor oil is made out of natural gas. Plastic is made out of natural gas. Everything's made out of natural gas, and you burn it for fuel. So when you look at it, looking down on the Arctic, it doesn't really look like that Arctic Ocean is bubbling with much. You see these lower concentrations is just sort of wafting along. If it was coming from, you would see that. You would see that pattern. This is the surface, by the way. This is the surface level. And pretty clearly, you can see that methane coming from the land-based sources in Russia and Europe. That's looking down from on the Arctic Circle, and you can, of course, see further down than that. This blob right here is from China. Let's step over here. Now this is Central Europe. Pretty clearly, you can see that. You know, it's got to be from heating, because this line hash mark here is the 0 hour, basically midnight universal time, which I believe is this line right here is the Greenwich line. So 0 hour is midnight, right? So it's in the middle of the night. Midnight is when you see the most methane come over Britain. This is Britain here, France, Spain over here, Italy, the boot. They get their energy from natural gas. A lot of it comes from Russia, right? I mean, that pretty much looks like, natural gas coming from homes and businesses and things like that, using natural gas for energy, for heating. Power, what have you. So this is December right now, December 15th. And you can see the king daddy of methane producers is rice production in India and China. I've said it a million times already. This is gas production. That looks like Texas. Yeah, gas production in Texas. There's a pipeline that comes from the Midwest all the way down to the southern tip of Florida. You know, there you can see that. See that right there? Yeah. Which carries 1 billion cubic feet of gas per day, all the way down to the southern tip of Florida, where I guess they turn it into liquefied natural gas, put it on ships, and send it, you know, abroad. Because everything is made out of natural gas, plastic, you know, everything. So there's that. That's the surface level. This is 850 hectopascals, which is a little higher up. And this is the interesting part here. You can see this pattern developing where it accumulates right around the pole. This line right here is 1 point. It's actually the North Pole. That's where the whole thing, you know, wraps together and meets up. That line right there is one spot. So it looks like it's stretched out along, you know, a long way, but really this is sort of like 1 point in a way. It's a tighter area. So that's 850 hectopascals, which is about, I think it's like 1,500 feet up, something like that, roughly, because it's, you know, it's like, looks like a landscape. It's better to keep track of a pressure than it is to an altitude. Altitude is meaningless. And notice also, you see more formaldehyde in the southern hemisphere. Formaldehyde is something you see throughout the southern hemisphere, and methane is in the northern hemisphere. It's like they're like apples and oranges, the southern and northern hemispheres. Okay, go up a little bit, 500 hectopascals, which is where they measure geopotential height. They measure the height of 500 hectopascals, and that's where you can see the air masses moving around. This is methane, so you can see how it accumulates. It moves towards the pole from lower latitudes. And you can see it at 500 hectopascals moving with the weather patterns. That's a pretty high concentration right there. Yeah, that's kind of ridiculous. 23, 20. That's what it looks like, this right here. 2,320 parts per billion, I believe. Yes, parts per billion. I'm looking for it. It's parts per billion. There it is, parts per billion. Okay. Okay. Then go up a little bit and it starts to dissipate. 300 hectopascals, which is above, I believe, 500 hectopascals is about 15,000 feet, something like that. 15,000, 20,000 feet, somewhere in that neck of the woods. So 300 hectopascals is a little bit higher than that. And you can see it's starting to dissipate. If you look at the ozone forecast at that level, you can see that the ozone is just, some of these areas are devoid of ozone at that same level we were just looking at. But then it sort of crops up here. All right. 50 hectopascals. Now the black here is it's zero. Zero methane here. So it's getting eaten up. It's eaten up. See how that's not quite as much CO2 there. Yeah. It's creating a pattern. And this is actually, this CO2 is actually like a little bit behind. And there's your ozone has been depleted. That green is a lower concentration. The beige and the yellow are a higher concentration. And you can see this big trench here that's right across the... And I don't know what that's going to do. I mean, what's that going to do? They say that the ozone hole over the Arctic closed up early this year. That there's no hole there. But what about this deal here around the equator? I mean, is that something that happens all the time? You know, I'm just asking. You know, maybe somebody out there knows. You know, you never know. Maybe nobody's saying anything because they're like, everybody's out there snickering. Saying, he doesn't know about that. Yeah, it happens every year. It happens all the time. I don't know. I've never seen no shit like that. But anyway, this is another thing, too. This is something, and I haven't really heard anybody refer to it this way, but I refer to it, I call it the Green Apple Express. You go over here and look at, okay, so this is anomalous temperature, right? North Pacific. Typically, sea surface temperatures are warm up here. Lately. Get warm sea surface temperatures over here, and sometimes where we've been getting a blue hole here, which is indicative of, they say, is indicative of when the thermal halide overturning current starts shutting down, because the thermal halide overturning current drops here up in this region. That's where you get your waterfalls that drop down and turn around and comes in, and then it rises up over here. So you get these. When the current starts shutting down, you get a cold spot down here near Australia, and you'll get a cold spot right here below Greenland. Which you can kind of see it a little bit, but it's not really all that prevalent necessarily. So the Green Apple Express essentially is what happens is you get warm conditions here, warm sea surface temperatures in the North Pacific right here. And so you get warm, moist air, and you get sort of a cold region in this spot here, around right over Baffin Island, right? And so you end up with this trail of moisture that comes up and over. And I refer to it as the Green Apple Express, where it comes up and over and dumps a bunch of precipitation and stuff. But this is what it looks like. This is the CO2. It's at 50 hectopascals, and so you can see that artifact there is essentially the Green Apple Express in motion. looking at it from this angle here, you can see how this temperature is pushing out into the North Atlantic. Right? So we're talking about, and how there's a little bit of a, you can see that there's a point here. Right? It looks as though it's just, the air is coming over. Now, at that level, you do have the polar vortex. It's high up and it moves rapidly. It will twist, depending on what's as an effect of global warming. It will start twisting and turning into like a figure eight kind of thing, and then you get these massive drops of cold temperatures. So this is looking a little different this year. I mean, you know, a feeling, you know, you can't, feelings are useless. That's why you got to look at the data. But I'll tell you, when I look at this, I don't know, there's something about this that just doesn't look good. And if it was me and I lived above the 40th parallel, which is like right here, I think I'd want to have my shit together. Again, this is the 2-meter temperature anomaly, and that's what it looks like. In any case, these areas where there are drought, Australia is surrounded by, you know, sea surface temperatures are anomalously cool. Have been. It's actually a little bit warmer lately. Like I said, here's Chile. This is anomalously cool temperature water. You know, that's going to cause drought. It just does. Now, I don't really see that pattern here for the areas that he was referring to as being on fire in Africa. But I got to tell you, you know, you go to Costa Rica or Ecuador or Colombia, you know, I just saw a video of some people that were that are traveling through Colombia. They went to a grocery store in Colombia, and they got plenty of fruits and vegetables on the shelves and shit. You know what I'm saying? And people ain't starving. You know, I just don't see it. You know, they're talking about all this dire shit, you know, and other than the fires. But, you know, I mean, fires, they have fires every fucking year. I mean, sorry, I hate to say it, but goddamn, you know, they have fires every fucking year. Australia, they have dry, you know, and they're decadal oscillations, you know, and El Niños and stuff like that. Now, I'm not going to say, you know, there's more CO2 in the atmosphere. But I don't see any of them jokers talking about this thing here. You know, that's it, man. I mean, you know, Elvis has left the building. That's what that stripe of CO2 at 1,000 parts per million. That's what that is. Elvis has left the building. And I don't really hear anybody talking about it. You know, I don't know if they're afraid to talk about it, or, you know, it's almost like there's just like total radio silence on that. Like they don't know how to talk about it, or, you know, or it's inconvenient. Because you look at that, and then you go over here and you look at the fucking 2-meter temperature anomaly, and I'll tell you, man, it just don't look all that compelling. Look at this. Look at this shit right here. Now, this is right under the equator. I mean, you know, that's right in the Amazon, right? And here, this is the equator's going right through here. That's right in the middle of where that big-ass band of carbon dioxide's flowing, man. You know what I'm saying? There's your, you know, right dead in the middle, right? And in that very same spot, shit, it's anomalously cooler. That's because you've got a greenhouse gas in the stratosphere. And so there's your trigger. So maybe we've seen the peak, the temperature peak, and we're in the downhill slide into a glacial period. I mean, that's what it looks like to me. But just to reiterate, as I was talking about Potholer earlier, and I already got rid of his, that's the subject of his video that was up a minute ago. You know, peer review is important, but you know, having been in academia, one thing is you get this, you start not being able to see the forest for the trees because you start parsing down deep into the details, and you get this tunnel vision. And I've always wanted to try to avoid getting that, to be able to maintain some kind of a global view on things. And then you got to have that for climate science. You got to know something about atmospheric chemistry, because those sharp turnarounds, and this is, you listen to any climate scientists and they will tell you that fast changes, fast turnarounds in the temperature of the planet must come from the atmosphere. It has to. Because of the heat capacity of the oceans, the amount of water that's in the oceans. You could make, I'm going to put it to you this way, you could make a corridor, a pipe, that has a cross-sectional area of, we'll say, a radius of a kilometer. And there's enough water on planet Earth that you could stretch that water pipe from Earth to like damn near Jupiter, filled with seawater, and drive a submarine almost to Jupiter through that pipe, through that column of water. So, yeah, that's a lot of water, and that's a lot of heat capacity. We're talking about currents that, like the thermal halide overturning current, it takes 1,500 years for that water to cycle all the way through because it goes all the way out, wraps around, goes out into the Pacific, and comes around and goes all the way back up here, There are decadal oscillations and centennial oscillations and all kinds of stuff, because this is a vast amount of water, and it has a high heat capacity, and the temperature at depth is very cold. That's why when you see people like Dr. Richard Lindzen, the professor emeritus at MIT for the past 30-some-odd years, he's just not really all that jumping up and down excited about climate change related to CO2. Because there's so many feedbacks involved. I could pretty clearly, to me, I'm seeing the footprint here of the mechanism that triggers a glacial period. It may not, if I'm wrong, God, I hope I'm right. Because if I'm wrong and they're right, if this guy, Dr. Carter, or Guy McPherson, for God's sake, those cats are right, that won't be good. But I don't think they are. I think that heat that they're talking about, that he's talking about, comes from the acidification of the oceans. Comes from the higher residence time. Oh, here's the other thing I wanted to show you. So this is 2006, and this is a model of the CO2. I guess they get it from satellite data. And this is probably October 26th, 2006. Pretty close to the month that I first discovered this band of CO2. Right here. So this is in 2006. This is the equator right here. So you can see there's not as much carbon dioxide there. I think we're looking at basically the total column. So right around May is when you have, and actually you see the accumulation. This starts, when does this start? It starts in January. So January is when your CO2, well, it's actually in the wintertime, your CO2 in the northern hemisphere starts to really accumulate. Right? So there's your accumulation of CO2. You'll notice that most of the land masses are in the northern hemisphere, so it's like the north and south hemispheres are like apples and oranges. And that's a pretty scary looking thing, right? With all that red and purple and stuff. It's purple, I guess, is the faux color that they have for high concentration. And you start getting to June. There's June. You get about to July. And real briefly here, July, I looked at every year, every day. I did a slide for every day of the anomalous temperature for the last 40 years since 1979. Every July, the temperature is nominal, and at the North Pole, right in this area, is nominal. Has been nominal every year for the past 40 years. Every year, without fail. And the most nominal temperatures throughout are right around the equator. That's just, that's what I found. I'm just a guy. So here we go. This is July. You notice, see how fast that carbon dioxide gets eaten up? That's from the dude on here will tell you. This link is in the description. That's how fast all that carbon dioxide gets eaten up by the plants. And he says, well, from emissions, we end up with more. Right, and then it starts building up again. So here we go. We're at November. That's November. We're almost to where we are now. Okay, now here we are. It's the 15th, December 15th, 2006. This is carbon dioxide. This is a model, but it's all up in the northern hemisphere. This is total column, right? And you don't really see that much by the equator. Okay, so this is at the equator, and this is at 50 hectopascals. So this is in the stratosphere. This is 60,000 something odd feet. Let's look at the total column. Total column, yeah. It looks ish. Not so much down in the southern hemisphere. You can kind of see that. China, of course, wafting off a lot of carbon dioxide. So basically there you have it. There's that. There's their model from 2006, South America, South Africa, Australia over here. And this is total column. And let's look at 850 hectopascals. Not so much. Surface. See, this is the kicker. Look at the surface. Now we're talking about 400-ish parts per million. You can watch the plant respiration and photosynthesis taking place. See how this is much lower. That's at the surface. Right. I mean, it 850 hectopascals, about 1,500 feet. Yeah. There's a little more accumulation there. So this thing in the stratosphere is definitely coming from methane. So place your bets, right? And this is what it's looking like right now. Get you some snow. Some pretty cool temperatures, right? Anomalous cool. Here's your average temperature. Right. So if something was going to run away, now that was the whole premise of the doomsday scenario, was that the temperature was going to run away, and it ran away. I mean, there it is, dude. I mean, what do you want? There it is. Boom, bam. That's from methane. That's the pulse. That's Elvis has left the building. Boom, there it is, and there's your temperatures, right? I mean, if that was the, if that was the doomsday scenario, we'd be frying right now. They said, well, they got fires burning down and Yeah, but do you know what I mean? It don't really look... I don't even think it's in the hundreds. See that green right there? That's like 10 degrees, less than 10 degrees, like 5 degrees Celsius. Right there. Is that, what is it, Tasmania? And down here in New Zealand and shit? Look at how, it's like 40 degrees down there. You know what I'm saying? Look at this. Look at what the temperature is in Chile. It's like freezing and shit. South Africa. It's almost summertime now. It's like high spring. December 20 something, probably the 21st, 22nd, somewhere in there. Christmas time essentially is the solstice, the winter solstice, which is the summer solstice for the southern hemisphere. And that's what kind of temperatures we're looking at. And really the tell of the tale, the pièce de résistance, there it is, man. There's your equator. Look at that blue there. Right on across. Look at this. I mean, there's India. I mean, what does that tell you? You know? Don't look like no fucking doomsday to me. I'm sorry. And I'm just looking at the data. I'm trying to make sense of it. And I don't know if these people really realize that there are people out there that are like, they're listening to them talking, they're like, okay, it's just talk. You're just saying, oh, wow, doomsday, man. There's more of this and that and the other thing in the atmosphere than there ever was. And blah, 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 blah. Well, you know, hasn't been that much in 40 million years. And blah, 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 blah. We're all going to die. Well, show me, motherfucker. I don't see it. I don't see it. I'm looking at this right here. Climate Reanalyzer from the Climate Change Institute, University of Maine. Bada boom, ching, bang. Bam. There you go. Show me, motherfucker. There it is. It's 1,000 parts per million of CO2 at the fucking 450 hectopascal level. And there's your motherfucking temperature. I need to see some... I need to see more than flapping lips out there to make me a believer. So, oh, you're really crude, man. I'm sorry. You know, and I don't, you know, listen, I don't want to talk bad about this cat here. I get it, you know. It's like, yeah, well, but we need to be concerned about it. Because ain't no telling what's going to happen. Just because this is happening now doesn't mean that the whole shit might turn around. Oh, that's another thing I got to tell you about. Residence time, there's a link in the description. The woman's name is Kristie Boering. It's another video, and it's all process. And these people are like not bothered. I got to make a little digression here. There's a building here that I did some work on. I was a day laborer. I actually was sweeping the floor. There's at a place called Nano, and it's a cooperative between the Department of Defense and National Institute of Health, something like that. Anyway, they had some pretty big wigs. The Department of, we're talking about the Joint Chief came in through the building, you know, and shit. And I think the Department of Homeland Security, a couple of big wigs came through there having to do with terrorism and things like that. And this, what they're basically working on is vaccines and things like that, biological warfare type of shit. This building is basically a doomsday building. You know, it's made to operate off the grid. It's explosive. It's made to withstand almost a direct nuclear attack. It's, you know, a serious building, and they came in to dedicate the building and to do this and that and all this kind of stuff. And it's, you know, it's kind of, they say it's a level 3 biohazard facility, but it's sophisticated. It's more than that. It looks, to me, you know, looks like a level 4. But anyway. This guy would come in, I would see this guy walking through the halls, and the dude looked like he just had breakfast with the motherfucking angel of death. Every time I ever saw this guy, this fucking dude had such a grim look on his face. He looked like that the world was swinging from a thread, and that the angel of death was standing there grinning from ear to ear with a hatchet, with a pair of scissors ready to cut that thread. That's what the dude looked like. He looked like shit was going on that was bad fucking news. Like he had the weight of the entire universe on his shoulders, this dude. And I can't remember his name right off the top of my head. I want to say he was the Joint Chief at the time. One of those that was, you know, a couple of them cats came through the building. Here I am pushing a broom. You know, I'm not going to go in there and hobnob with these guys. Fuck it. You know what I mean? So, but yeah. And, you know, people are talking about, well, it's a climate emergency. Well, it might be. I mean, it is. That's serious, for sure. But serious in what way? Might be serious in terms of a whole bunch of motherfucking snows about to drop on people above the 40th parallel. That's what I'm talking about. I'm just, you know, what I'm basically trying to tell you is that I'm not just here fucking talking out the side of my ass. I used to do other material, you know, and then I started doing this shit, and I saw Guy McPherson. I said, well, let me pry into this and see what the deal is. You know, they're talking about the whole world's going to die. This guy right here was just talking about it. Dr. Peter Carter, he says, oh yeah, man, with the amount of gases going up and stuff, we're talking about a collapse of the biosphere. Man, it's talking about the fucking planet's going to die. This guy right here, that's what he's saying. The link is in the description. Whole planet's going to die. Collapse of the biosphere. That's one of the words that came out of his mouth. Collapse of the biosphere. And I'm sorry, and you know, it's just me, and I'm a little fucking you, whatever. I'm not a big guy. I'm a little you. I'm a little cog, a small, tiny cog in a little wheel. Spinning over here, you know. I don't see it. Not from CO2. Not from those small amounts of CO2. Not with that huge, giant fucking ocean here that just eats CO2 like it's nothing. Turns all that CO2 into carbonate compounds, and then they just rains out onto the ocean, harmlessly onto the ocean floor. Now, deregulate sulfur emissions, and we'll have a different conversation. Start acidifying that ocean, and it will be different. Then that'll get you some doomsday. You know, have a large super volcano go off and distribute a whole bunch of hydrogen sulfide, sulfur dioxide into the ocean. And you got a different story. Acidify those oceans and then have a mass die-off of ocean life. But where it is now, you know, unless you kill the ocean, I mean, that's how you have that doomsday warming shit. You got to kill which came first, the chicken or the egg? They're saying the global warming kills the ocean. I'm like, no. Killing the ocean brings the global warming. The CO2 acidifies the ocean. No. Acidification of the ocean brings the CO2. How can you even possibly think that CO2, that at the rate that we're putting in there, could ever acidify that ocean enough to do that kind of damage? It's just impossible. It's not possible. It's ridiculous. It's absurd. Now, you give me some sulfur dioxide and hydrogen sulfide, which rapidly becomes sulfuric acid, H2SO4. H2SO4 has a pH of 0. A pH of 0. You don't need that much of it to acidify the oceans. And when you acidify those oceans, you liberate the CO2 from the carbonate. Not only that, but you liberate the CO2 from the carbonate on the land masses. So, you know, you get that from a meteor strike. You know, if we get hit by an asteroid, yeah. And all of that stuff, and I've said this in previous videos before, all that stuff happened during the Permian Triassic. We were, you know, the Earth was hit by a massive rock from space that caused a ripple to go all the way around the globe and meet on the antipodal side of the planet and pop the Siberian steppes like a zit. 6 trillion tons of sulfur compounds were released into the atmosphere. And like 1.5 or 2 trillion tons, I think it was about 2 or 3 trillion tons of carbon compounds were released into the atmosphere. in a relatively short amount of time. The oceans had a pH of lemon juice. And at that time, 30% of the terrestrial life survived. So, I mean, how are you going to talk about, it's like you're talking about, that human beings are going to become extinct? I don't think so. It's just preposterous. So, the only reason they're doing that they're talking about these things in the face of not really having that much evidence, is because it has a negative effect on the sentiment of the public. That's why they do it, But there are other environmental issues at play. And frankly, if you want to have carbon zero, then, the way to go is NuScale, modular, nuclear power. And they don't pay me. Nobody pays me. I don't get paid to chat up these people, but that's the one that makes the most amount of sense. Their safety boundary is the plant boundary, So I've talked about them before. NuScales, that's the way to go. Pebble bed, nuclear reactor. Instead of bird blenders, the global warming thing was just an excuse to build a bunch of bird blenders made by companies in Sweden and Norway and shit. Estonia. This constellation of countries up here, Finland, Norway, Estonia, and Sweden, they all make machine and electronic stuff. They're in the anti-global warming business. Essentially, that's, Vattenfall, they've got more of wind farms than anybody else in the world. Not just the one in Britain, but they've got a bunch of them. Vattenfall runs power generation in like most of Europe. They do it all, as evidenced by the fact that you can see all the natural gas wafting off of Sweden right there. So, it's crazy. But that's all I got for now. My name is R. Crosby Lyles. This has been a really long, perseverating video. Thanks for watching. If you live above the 40th parallel, you want to be prepared with extra provisions. Alternative communication devices like ham radio, shortwave radio, CB radio even. Extra medication for you and your pets, stuff to barter and trade. A way to get snow off your roof, and a bunch of other stuff. And that's all I got. My name is R. Crosby Lyles. Thanks for watching. See you.